Yes, hello, Ali. Can you see the screen?
Yes, sir.
So we were done till here, and we are going to move on to some more questions. And this one, I guess this will be easy. Not tough. Which of the following is dependent on temperature? So any concentration term that has the volume term in it, it is going to be dependent on temperature. Yeah. So take 1 minute, not more than that. Assalamu alaikum, Nabil. Am I audible?
Yes, sir.
Okay. Nabil, where are you from? I think this is your first class, right?
Yeah, first class, Saudi Arabia.
Where in Saudi?
Al Khobar,
Okay. Super. And where are you originally from?
Kerala.
Originally from Kerala. And where did you do your schooling? Like which school did you go to?
Indian school, Daman.
Indian International School, the one, that one?
Yeah.
So we have done certain sections of the first class, that was some basic concepts in chemistry. And basically we have done mole concept and we have done concentration terms. Okay. So stoichiometric calculation is remaining in this. So we are going to do stoichiometric calculations today. And there are certain questions of concentration, only 2 questions of concentration term. Another major thing that we will be doing today is solutions. Okay, so already the concentration terms of solution is already covered. So in solutions, we will go from Henry's law, Rod's law, and qualitative properties, then the deviations in Rod's law also. Okay, so these are the major topics, and one major is stoichiometry.
Okay.
And we mostly will be doing questions, and with each questions you will be learning some theories also. Okay, so we cannot do complete theory and then questions because time is very less. So we'll be looking at most of the questions, and with each question you will be learning a bit of theories also. Okay. Make sense? So this is the first way, which of the following is dependent on temperature. So any concentration term which has a volume component in it, that means it has volume in it, its formula, then it is going to be what? It is going to be temperature dependent, because volume of a liquid, it increases or decreases according to the temperature. So molarity, if I see, it is what? It is equal to number of moles of solute divided by the volume of solution. So we have volume. So this will be what? This will be temperature dependent. In mole fraction, we only have number of moles of solute divided by number of moles of solvent plus number of moles of solute. So it is completely number of moles. There is no volume term here. And number of moles, it also only depends on what? Only depends on the mass of the solute. Okay. Next, we have the weight percentage. So it is basically mass by mass. So don't have any volume component. Molarity is also number of moles of solute divided by the mass of solvent. In kgs, it is completely dependent on mass only. So we have the correct option, this molarity. That was the first option. Moving on. We have next question, that is, if 500 ml of a 5 molar solution is diluted to 1500 ml, that means you add how many more? You add 1 liter more water. What will be the molarity of the solution obtained? So I will give you guys 2 minutes for this. If you can try, then you please try this. Now, if you try, you will get the answer also. You don't need any theory. Right now you have 500 ml, and then after that you will be having how much? You will be having 1500 ml. Okay. So please try this. You write 5 molar, it is equal to 5 moles in 1 liter. So in 500 ml, how many moles of solute will be there? And then you can do it. You guys have 2 minutes. 2 minutes over. See, in this cases of dilution, all we have to do is the only thing constant in the solution that we have earlier, without dilution and after dilution, will be the number of moles of solute, because we have added solute here. So you have a number of moles of solute is constant here, and we are adding then what we are adding only water. So we are not changing the number of moles. Okay, Aram and Arya have got it. So number of moles is going to be a constant. And if you look at the formula for molarity, it is equal to number of moles of solute divided by the volume. So number of moles of solute will be equal to molarity into volume. And we can say that number of moles of solute, that is before, will be equal to number of moles of solute after dilution. So before dilution, I can say number of moles of solute is M1V1, which will be equal to M2V2. And this is the formula for dilution. So after dilution, whenever you see any questions on dilution, you will see M1V1 is equal to M2V2. So initially they are saying that we have how many? We have 5 molar, and the volume it is equal to how much? 500 ml. This will be equal to molarity here. We need to find this molarity M2, and V2 is how much? It is equal to 1500 ml. Okay, so M2 will be equal to 5 into 500 divided by 1500. So we can cancel these zeros, and then 15 threes are, and 5 divided by 3. This is approximately equal to how much? 15, 15, and 15 by 9. 15 by 9 will be 1.66 molar. Okay. But there is one thing that I want all of you guys to remember, is that 1 upon 9 is equal to 0.11111. Okay. It will go on. 2 upon 9, it is equal to 0.22222, and so on. And similarly, 3 upon 9 will be also equal to 0.333, and so on. So whenever you have anything such as, for example, you have 5 divided by 3, na? So I mean, you can do it like 5 divided by 3 also. But if you see here, 5 divided by 3, and multiply 3 and 3 above and below, it will become 15 by 9. So you know that 9 ones are 9 ones is what? 9. And how much is remaining? 6 is remaining. So 0.666666 will be there. If it was 16 by 9, it will be 1.77777, and so on. Okay. So this is something that you should remember, that 1 upon 9, 2 upon 9, 3 upon 9 is equal to 0.111, 222, 333, and so on.
No,
Please
that's
copy this
useful.
down. Yes. What, Nabil?
No, that's useful.
That's useful for quick calculations. Whenever there is something that will increase the speed of your calculation, I will try to include that also. And one more suggestion regarding the solving of numerical is that, for example, if you have to calculate, let us suppose, number of moles first, and then you have to calculate number of moles of calculate volume, let us suppose, or mass. Then when you have number of moles, please keep it in fractions and don't divide it and get the decimals. You have to get the decimals only for the last answer. Okay, the last answer that you have to. So in steps, you will keep the fractions until unless it is obvious that you should divide it. For example, if it is something like 10 upon 2, obviously you have to do it 5. But if it is something around 33 upon 17, 33 upon 19, this type of odd numbers, and you keep it as fractions, don't divide it. So moving on to stoichiometric calculations. Is anyone writing? No.
What's up?
Are you guys writing?
No, no.
Writing? Now, in stoichiometric calculations, you will need a bit of theory. So the only theory that I will teach you guys is regarding moles to coefficient ratio. Moles to coefficient ratio. Now, what is moles to coefficient ratio? For example, you have N2 plus H2 gives NH3. So you will balance this reaction first of all. So when you balance, you will write 2 here, and there is 6 hydrogens, so you will write 3 here. Now, what does moles to coefficient ratio means? So there is certain amount of nitrogen that you are going to take, that will be 14 grams, 13 grams, whatever it is. And from that, you will calculate the number of moles of N2. and then you will divide by the stoichiometric coefficient of N2 that is equal to 1. Okay. So whatever numbers that is before the chemical species, that is stoichiometric coefficient. Then for H2, for example, you have 6 grams, 7 grams, whatever actually you are having, you will take that and you will calculate the number of moles of H2 and then you divide by 3. And for NH3, you have to do the same thing, 2NH3 divided by 2. Okay. So this is moles to coefficient ratio. Does this make sense? Yes or no? Please tell me. You will calculate the number of moles. Please remember that when we say the reactions, we also say sometimes when 1 mole of N2 reacts with 3 moles of H2 gives 2 moles of NH3. So when we are, I'm not meaning that moles when I write N number of moles of N2. Okay. So those are stoichiometric coefficients. Number of moles will be the amount will be given to you guys, and then you divide it by molar mass to get the number of moles of nitrogen that you have in order to react. The number of moles of, let us suppose you want to make NH3, then what is the amount of NH3 you want to make? You divide that by molar mass of NH3, you will get the number of moles. And then you can calculate, and then you can determine the moles to coefficient ratio. Is this clear? Yes or no? Please tell me. Alia, Iram, and Nabil.
Yes, sir. Yes, sir.
Okay. Now there
Yes,
will be
sir.
only 2 types of questions related to stoichiometric coefficient. There will be questions in which you have been given when only one reactant is involved. Okay, in calculation. In question, in question. क्या मतलब है? Reaction में, I'm not saying in reaction. Please understand that. If you have been given the amount of only one reactant, for example, they are saying you have this many amount of N2, what will be the amount of NH3 that is produced? We have this many amount of H2, what is the amount of NH3 you have? It is produced. Or they are saying we have to produce itna amounts of NH3, we have to produce this much amount of NH3, what is the amount of N2 required? Okay. So if it is like that, so all of these are involving only one reactant. Okay. They are giving you the amount of only one reactant, or they are asking you the amount of only one reactant. In these cases, what you have to see, it's very easy. The most of coefficient ratio को हम MCR से represent करेंगे, and we'll say MCR, moles to coefficient ratio of the reactant, will be equal to moles to coefficient ratio of the product. Okay. This is the only thing that you have to remember when you have been given only one reactant. And once you write this equation, you can solve it. Okay. Solve हो जाएगा अपने आप. You don't have to worry. This is the starting point. Once you write MCR of reactant, then you will calculate the number of moles of the reactant divided by stoichiometric coefficient, number of moles of product divided by stoichiometric coefficient. अब देखिए इसी को कैसे लिख सकते हैं? Given mass of N2 divided by molar mass of N2 into 1, which will be equal to given mass of NH3 divided by the molar mass of NH3 into 1. Now here you must be given the amount of N2. You know the molar mass of N2. You need to find out, I'm putting it in red, you need to find out the amount of NH3. But you also know what this will be 2. You know the molar mass of NH3. So here you can see that there are multiple variables, but only one variable is missing. So it will give you a linear equation in one variable and you will solve it. So the starting point I'm telling you, and with each and every questions, we will be looking at the different types of question and what is the missing variable there. But you have to always start with MCR of reactant is equal to MCR of product if only one reactant is involved. Now the other type of question that you will be getting is when 2 or more reactant is involved in question 1. ठीक है, कहाँ पे? In question. So they are saying that you have this much amount of N2 and this much amount of H2. What is the amount of NH3 formed? Now in this case, what happens? Limiting reagent comes into play. So first of all, you will have to calculate you have to determine what is the limiting reagent. In order to determine that, you have to calculate the MCR of each reactant. First step is calculate MCR of each reactant. The one with least value will be limiting reagent. Okay. So you will calculate the MCR of N2, MCR of H2. If you have 3 reactants, then if you have been given the amount of 3 reactants, then you will calculate for the 3 reactants. And once you're done, what you will do? The one with the least value of, not number of moles, number of moles divided by the stoichiometric coefficient. है ना? Moles to coefficient ratio जिसका सबसे कम होगा, the one which is least, it will be what? It will be limiting reagent. That second point will be MCR of the limiting reagent will be equal to MCR of the product. These are the two steps. So by the way, Nabil, do you understand some Hindi?
Yes, sir. I can understand.
Okay. So please copy this down. Raise your hand once you're done writing. Please raise your hand once you're done writing.
Sir, finish.
Let's see this question. यहाँ से ना बस आपको हम एक चीज बता देते हैं, that is new, which is not related to directly stoichiometric calculation. It is 20% of pure limestone. The right option for the mass of CO2 produced by heating 20 grams of 20% of pure limestone. What is this 20% means? In the 20 grams, only 20% of CaCO3 is there. है ना? तो 20%, 20 ग्राम का 20% कितना होगा? Tell me guys, what will be the 20% of 20? 20% प्योर लैमस्टोन का मतलब आप ऐसे आसानी से कर सकते हैं, 100 ग्राम में आपके पास कितना होगा? 20 ग्राम्स। 1 ग्राम में आपके पास कितना होगा? 20/100। तो 20 ग्राम में आपके पास कितना होगा? 20/100 multiplied by 20. 0 can cancel and you will get 4 grams. So effective amount of CaCO3 that you are having is equal to how much? Only 4 grams of CaCO3. So as you can see, you have been given the amount of one reactant. और आपसे क्या पूछा हुआ है? What is the mass of CO2 produced? So आप कीजिए please, MCR of reactant is equal to MCR. So you will take 4 gram as what? As the mass of CaCO3. ठीक है? Then you will do mass upon coefficient ratio. You first of all check whether this particular reaction is balanced or not, and then you can start doing it. ठीक है? I will give you guys 3 minutes, and once you're done, you will send the answer to this number. I want to see like how you are doing this, and I want to see like if you're making any mistakes in the steps. Okay, so please save this number. Once you're done, you will send the answer to this. Please start doing, okay? The 2 minute is over. Can you guys please send what? Yeah, Nabil, tell me.
Option A, right?
So you have got option. No, we will see. We will see.
Okay, I'll see.
You sent the answer.
Yeah, I will
Alia
send.
and Aram.
Just a minute, sir.
I hope you have calculated the molar mass of CaCO3 also. You did not even start, Alia.
No, sir, I couldn't do it.
आप कम से कम वो तो लिखते हैं ना, MCR ऑफ रिएक्टेंट इज इक्वल टू MCR ऑफ प्रोडक्ट, एटलीस्ट यू राइट दिस पार्ट, MCR ऑफ रिएक्टेंट इज इक्वल टू MCR ऑफ प्रोडक्ट। जब तक ना स्टार्ट नहीं कीजिएगा ना तो मुश्किल होगी, तब थोड़ा सा आपको हिम्मत करना पड़ेगा, ठीक है। ओके लिया, सी हियर। अब आप ही बताइएगा, ओके, ठीक है। टेल मी, MCR of react means number of moles of reactant, make sense, divided by the
Yes.
coefficient stoichiometry, ठीक है। What is the reactant?
CaCO3.
So number of moles of CaCO3 divided by what is the stoichiometric coefficient of CaCO3? Quickly, yeah, quickly. What is the number? क्या नंबर है CaCO3 का in the reaction चलना?
4 by
How?
100.
नहीं, this is I'm asking मोल्स टू कोएफिशिएंट रेशियो आपको निकालना है ना, नंबर ऑफ मोल्स हो गया, कोएफिशिएंट क्या है CaCO3 का? डू यू अंडरस्टैंड व्हाट आई व्हेन आई से कोएफिशिएंट? यस आलिया, स्टोशियम, यस आलिया जल्दी बताएंगे प्लीज, टेल मी, डू यू अंडरस्टैंड व्हेन आई से कोएफिशिएंट ऑफ CaCO3?
No, sir.
अच्छा देखिए, जैसे यहाँ पे हमने लिखा था ना, हाइड्रोजन का कोएफिशिएंट क्या है 3, NH3 का कोएफिशिएंट क्या है 2 है, N2 का कोएफिशिएंट क्या होगा, टेल मी, व्हाट विल बी द कोएफिशिएंट ऑफ N2?
1.
1। जैसे आप लोगों ने बचपन में पढ़ा होगा ना, 2x² प्लस 3x, तो यहाँ पे x स्क्वायर का कोएफिशिएंट 2, वही सेम है, ठीक है, इट्स द सेम थिंग। ओके, सो व्हाट इज द कोएफिशिएंट ऑफ CaCO3?
1.
1. This will be equal to number of moles of product. What is the product that we want? We want CO2. Make sense? We don't have to look at CO. We
Yeah.
have to find for CO. So CO2, number of moles of CO2 divided by what is the coefficient of CO2? Coefficient of CO2?
1.
Number of moles of CO3, CaCO3 will be equal to 4 upon the molar mass of CaCO3. I hope you calculate it as 100. This will be equal to number of moles of CO2. What do we need? We need moles of CO2? No, we need mass of CO2. So I will write the mass of CO2 divided by number of moles क्या होता है? Mass by number of the molar mass of CO2. I can write this, the mass of CO2, it is equal to 4 upon 100 into 44. Correct है? Yes or no, please tell me. Wait a second, 4 upon, मुझे 100 ही आ रहा है CaCO3, तो 4.44 ग्राम्स होता ना, 4.44 ग्राम्स तो नहीं, देखने से एक सेकंड, 40 प्लस 12 प्लस you have 48, 48 नहीं, it will be 100, 100 है,
Yes, sir, 100 है.
100 नहीं होगा, 110 होगा शायद।
Sir, 0.04 होगा, right? So, and 0.04 into 44, 1.76 gram.
What is this, sorry?
Sir, जो 4 by 100 आपने लिखा है, right? उसको हम 0.04 लेंगे, and 0.04 into 44 is 1.76 grams.
That will be, ठीक है, my bad. I was thinking something. Yeah, 4 into 4 into 44 will be 176. This will be upon 100. Will be upon 1.76. Yeah. Sorry, I was thinking something else. Copy this down. ये हो जाता ना आलिया, ये सुनो पिछली,
Yes, sir.
क्या ख्याल है? हाँ। यहाँ स्टार्ट कर दीजिएगा प्लीज, ठीक है ना, कुछ नहीं हो तो स्टार्ट कीजिएगा, जो है दिया हुआ उसी पे लिखते रहना आपको, कुछ ना कुछ, ठीक है, जो दिया हुआ उसी से आप कुछ ना कुछ निकालिए, तो फिर आपको दिमाग काम करेगा, छोड़ के मत रखिएगा, आई थिंक
ठीक है, सर.
ठीक है, वेरी गुड नबील। Done copying, Alia?
Yes, sir.
Yes. What mass of pure CaCO, 95% pure CaCO3 will be required to neutralize 50 ml of 0.5 molar HCl solution according to the following reaction? Now, then this type of questions that you are having, here you have to again calculate the same thing, the number of, basically, but you have to see that how many moles, like what is the amount of CaCO3 that will be able to react with HCl. Okay, so you are again here, you are doing with reactants only. So when you are only dealing with reactants, then MCR of one reactant will be equal to MCR of the other reactant. Okay, but here you have to see a 50 ml of 0.5 molar HCl. This will give you the number of moles of HCl. How? You know that molarity is equal to number of moles by volume. Molarity into volume will be equal to number of moles. So you will get the number of moles of HCl using molarity into volume. 95% pure CaCO3, what mass of 95% pure CaCO3 you will need. Okay. So once you get the mass of CaCO3, then you will have to adjust it into 95%. So first of all, you calculate the number of moles of CaCO3 that will be required to neutralize this many amount of HCl. So आप यहाँ पे क्या कीजिएगा, number of moles of CaCO3 divided by coefficient is 1 will be equal to number of moles of HCl divided by 2. Number of moles of HCl you can calculate using this formula. Please convert this into liters. Yeah? When you calculate the number of moles of HCl, you will get the number of moles of CaCO3. Then I will explain. ये 95% से कैसे डील करना है? Take again 2 minutes for this. See you guys. number of moles of HCl will be equal to, if you want to convert 50 ml to 50 upon 1000, this will be now liters, into 0.5. This will be equal to how much? This will be equal to 25 upon 1000, 25 into 10 to the power minus 3 moles. So this much amount of HCl we are having. So what you needed to do was number of moles of CaCO3 that will be required will be equal to 25 into 10 to the power minus 3 divided by 2. This many moles of CaCO3 is required. So this will be equal to 12.5 into 10 to the power minus 3. So this is what? This is the number of moles of CaCO3 that is required. Now, what is the mass of CaCO3 that will be required? So number of moles is equal to the mass of CaCO3 divided by the molar mass of CaCO3. This is equal to 12.5 into 10 to the power minus 3. Now, mass will be equal, the given mass will be equal to 12.5 into 10 to the power minus 3 multiplied by the molar mass is 100. So this will be equal to how much? 12.5 into 10 to the power minus 1 because 10 to the power 2 minus 3. It will be 1.25. So this is the mass of CaCO3 that you require. But the CaCO3 that we are having, it is 95% pure. That means if I take 100 grams, only 95 grams will be CaCO3. And we need exactly 1.25 grams of CaCO3. The pure the amount of CaCO3 that should be present should be 1.25 grams. So the mass of whatever impure CaCO3 that we are taking, it should be more than 1.25 grams. This is 95% CaCO3. So now tell me, without doing any calculation, what will be the correct option? Which one should be the correct option? Like we have 95% of pure CaCO3. So how much amount of impure we have to take so that we get 1.25 gram as the pure CaCO3? I hope you are getting my point. Like in 100 grams, we have 95 grams. So what amount we have to take in order to get 1.25 gram as the pure CaCO3? Send your answer in the Zoom chat. Yes, that Nabil earlier, 1.32 grams. Because that is the nearest that we are having. 1.25 gram अगर हम impure ले लेंगे तो it is not going to give me 1.25 gram. 1.25 gram से कम हमको pure मिलेगा. ठीक है. Now how to actually exactly calculate this value? It is also not very difficult. What you can do is when you are saying a 95% pure, it means that 95 grams of CaCO3 in 100 grams of that substance. 1 gram में 1 gram of it is present in 100 upon 95. How much do we need? We need 1.25 grams. So 1.25 gram will be present in 100 upon 95 into 1.25. But यही है कि इतना कैलकुलेट करने से अच्छा है कि you can approximate कि we would need slightly more amount of the impure part. ठीक है, तो 1.32 grams will be the correct answer. Now try this. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. Haber's process is actually this reaction N2 plus 3H2 gives 2 moles of NH3. Okay. So you have to produce, they are asking for number of moles of hydrogen. That means only one reactant is involved to produce 20 moles of ammonia. Please try this. I think we'll be doing stoichiometric calculations only today. All the solutions say they don't ask much questions, like approximately 1 or 0 questions are asked. Zero, I mean, the average is 0.5 in the past years. Every alternate years they ask solution, you can see. But this stoichiometric coefficient, some basic concepts in chemistry, they ask every year. No, Iram, I don't think that is right. Number of moles of hydrogen molecule required to produce 20 moles of ammonia through Haber's process. फिर से कीजिए. Maybe you're. अच्छा, sorry. नहीं, correct है. My bad. हमने वो गलत देख लिया था. My bad. Correct है. This does not even require any calculation, so I will give you 1 minute. The way you are going to read the question ही आप जो जिस तरह से आप सवाल को पढ़ेंगे ना, the reaction पढ़ेंगे, तो उसी में ही आपको हो जाएगा. Now, see, there are, I mean, you can do the calculations and everything, or if you read this reaction, if you read this reaction statement like this, like 1 mole of nitrogen will react with 3 moles of hydrogen to give 2 moles of NH3. Okay, so 3 moles of hydrogen is giving 3 moles of hydrogen is giving 2 moles of ammonia. If I have 30 moles of hydrogen, so I multiplied 30 here, it will give me 20 moles of ammonia. Right, so you can directly do 30, or if you want to write the MCR method, so MCR of the reactant will be equal to MCR of the product. So number of moles of H2 upon 3 will be equal to number of moles of NH3 divided by 2. Number of moles of H2 will be equal to 3 into number of moles of NH3 that we require is 20 divided by 2. So 2 tensor, and this will be also equal to 30. So 30 will be the answer. So you can do it in any way. Please copy this down. And please copy it, and you can try this question. अच्छा, इस क्वेश्चन को मतलब हम ही कराएंगे, इसको भी छोड़ दीजिए. ठीक, you can try this one. What is the mass of precipitate formed when 50 ml of 16.9% HNO3 is mixed with 50 ml of 5.8% NaCl solution? Okay, please try this. So this is 50% 16.9. This is by mass. If they are not given anything, then it means that they are giving the values in mass percentage. So 16.9% of AgNO3 solution will have 16.9 grams of AgNO3 in 100 grams of solution. Just, but here they are saying that it is only what 50 ml we are having, 50 ml of the solution. ठीक है, तो 16.9 का आधा कर लीजिएगा आप, and similarly for 5.8 का भी आपको आधा करना पड़ेगा, because we are not having the complete 100, we are having only 50. Take 2 minutes for this. Just give me a second, guys. I will reshare my screen.
सर
Yeah, tell me.
सर इसमें फाइन क्या करना है?
What is the mass of the precipitate form? अच्छा, ये मतलब जब आप AgNO3 को मिक्स करेंगे AgCl के साथ तो क्या बनेगा?
HCl.
बनेगा ना? मेक सेंस ना? AgCl प्लस NaNO3. ठीक है, तो AgCl क्या होता है? प्रेसिपिटेट होता है. So you have to calculate the amount of AgCl. You can see that here we have two reactant given. तो यहाँ पे आपको निकालना पड़ेगा क्या? You have to also calculate the limiting reagent. देखिए how to do this. First of all, I will calculate the molar masses of the required species. So for AgNO3, this is equal to 169.8. Then we have NaCl. NaCl will be 23 plus 35.5. That will give you 58.5. These are the molar masses of AgNO3 and NaCl. Now, what is the mass of AgNO3 that we are having? This is equal to 16.9 ka half. Why? Because 16.9% in 100, how much we have? 16.9 grams. So in 50 ml, how much we will be having? We will be having half of that. Similarly, the mass of NaCl that we will be having will be equal to 5.8 ka half. Because here also we are taking that much of 50 ml of NaCl. Now we have got the mass. We will calculate the number of moles. Number of moles of AgNO3 will be equal to 16.9 divided by 2 multiplied by this is the mass divided by molar mass 169.8, and the number of moles of NaCl, this will be equal to how much? This will be equal to 5.8 divided by 2 into 58.5. So 16.9 को अगर हम 10 से multiply करेंगे, then I will get approximately 169.8. So I will write it 10 here. Similarly, here also 10. The number of moles of AgNO3 that we are having, this is equal to 1 upon 20. Number of moles of NaCl that we are having, this is also equal to 1 upon 20. So you can see that both of these are what? Equivalent. And right now, both of them are what? Equal. The number of moles of AgNO3 as well as number of moles of Na is what? Same. And then they are asking what is the number of moles of AgCl will form. So according to the reaction, if you see, 1 mole of AgNO3 react with 1 mole of NaCl will give you 1 mole of AgCl. So this much amount of AgNO3 will react with this much amount of NaCl, and it will give you this many amount of number of moles of AgCl will be also equal to how much? 1 by 20 only. Okay. So once you have 1 by 20, now you can get the mass of AgCl is equal to 1 upon 20 multiplied by what will be the mass of AgCl, molar mass of AgCl. It will be 107.8 plus 35.5, which is 143.3. So 143.3 divided by 2. 143 का half कितना होगा? Approximately 70 approx आएगा ना? तो 71.65 divided by 10 हो जाएगा because we will divide by 2 ना. So it is 7.165 grams. So the nearest integer will be 7 grams. That will be the answer. Here we did not do the MCR method because यहाँ पे directly आपको मिला था 1 mole of AgNO3 will react with 1 mole of NaCl will give you 1 mole of AgCl. 2 mole रहता है तो 2 mole से आपको 2 mole मिलता है. Here also having 1 by 20 moles or by 1 by 20 moles will give you 1 by 20 moles of AgCl. Once you get the number of moles of AgCl, multiply it by the molar mass of AgCl to get the mass of AgCl. Does this make sense? Yes or no? Please tell me. Alia, Adam, and Nabil.
Yes, sir.
Yes, sir.
Can we try this? In an experiment, it showed that 10 ml of 0.05 molar solution of chloride required 10 ml of 0.1 molar solution of AgNO3. Which are the following formula of the chloride? X stands for the simple unit other than Pb. ठीक है, यहाँ पे देखिए, like what this question is saying. From here again you are going to calculate the number of moles. Okay, again going to calculate number of moles. For example, if you have, let us suppose X Cl and there are Y amount of Cl. Okay, there is Y amount of Cl plus AgNO3. So it will give you, so what would happen? Wait a second. It will give you AgCl. Okay, and something else. We don't worry about it. Something else. Now, what is the amount of AgCl we'll be getting? We'll be getting Y amount of AgCl. And if we are getting Y amount of AgCl, we would need Y amount of Ag also. So we would need Y amount of AgNO3. Okay. So depending on what is the number of fluorine atom present in the chloride, we would need the moles of AgNO3. Okay, so this is the basic idea of the question. How to do this now? So we have 10 ml of 0.5 molar solution. That means what will be the number of moles? The number of moles will be equal to 0.5 moles. Or rather 0.5 millimole I am saying. Okay, millimoles. And here how many moles we are having? We are having 1 millimole, I guess. Does this make sense till now? Like you have to calculate the number of millimoles. Make sense till now? Yes or no, please tell me. Guys, no.
So can you explain again?
Molarity, it is equal to number of moles divided by volume. So number of moles will be equal to molarity into volume. That's what we did now. Volume multiplied by molarity. And because this was, I mean, milli का मतलब क्या होता है? 10 to the power minus 3. तो देखिए, मतलब जो मिली का आपको थोड़ा समझ में नहीं आ रहा होगा. See, number of moles will be equal to molarity is equal to 0.05 multiplied by the volume. Volume is equal to 10 ml. 10 को हम liters मिलेंगे, तो it will be 10 upon 1000. ठीक है? So this will be equal to how much? 0.5. 5 into 10 करेंगे तो divide by 1000. ठीक है? That means 1000 को हम ऐसे लिख सकते हैं into 10 to the power minus 3. Now what is 10 to the power minus 3? 10 to the power minus 3 को तो मिली बोलते हैं. Does this make sense?
Yes, sir.
ठीक है. Okay. So we have this many amount of the chloride. 0.5. अच्छा, अब हम यहाँ पे ऐसे करेंगे. 0.5 को हम ऐसे लिखते हैं कि 1/2 of XCl(Y) plus 1 mole of AgNO3. That means half moles of the chloride reacts with 1 mole of AgNO3. Make sense? Yes or no? Please tell me.
Yeah.
Okay. Now, if I want to, I need to do everything as 1. Then what I would have to do? See, I will have to do this. Cl is what? Cl is Y, no? Y amount of Cl. So you can see that half moles of this chloride is reacting with 1 mole of AgNO3. That means from this half moles of chloride, how many chlorine atoms will be getting? The chlorine atoms that will be getting will be equal to 1. Does this make sense? Because it is reacting with 1 moles of AgNO3. And with half moles, I'm going to get 1 chlorine atom. That is why the number of chlorine atom in the molecule will be equal to 2. क्योंकि अगर हाफ से आपको एक मोल क्लोरीन मिल रहा है, तो अगर आपके पास 1 मोल होगा पूरा का पूरा मॉलिक्यूल का, देन यू विल गेट 2 मोल्स ऑफ क्लोरीन एटम. ठीक है, दैट्स रिलेशन दैट्स यू कैन सी हियर आल्सो. 0.5 से आपको कितना AgNO3 चाहिए? 1 मोल ऑफ AgNO3. you need double of that. ठीक है, so you would be having 2 chlorine atoms. That is why you need 2 AgNO3. अब देखिए XCl2 plus 2 moles of AgNO3. ठीक है ना. अब देखिए यहाँ पे सही पैटर्न ना, 1 मोल ऑफ द क्लोराइड रिक्वायर्स ट्वाइस दैट ऑफ AgNO3. यहाँ पे भी वही हो रहा है, 0.5 और यहाँ पे 1 है. सो 0.5 रिक्वायर्स ट्वाइस, क्या हो जाएगा? 1 हो जाएगा. ठीक है, तो व्हाट विल बी द करेक्ट ऑप्शन? द करेक्ट ऑप्शन इज गोइंग टू बी XCl2. Now try this one. Now all of these are going to have, I think, two reactions involved. When 22.4 liters of H2 is mixed with 11.2 liters of Cl2 each at STP, HCl is formed. What is the amount of HCl formed? You can have, so from 22.4 liters, you will calculate the number of moles of H2. From 11.2 liters, you will calculate the number of moles of Cl2. And then you will see which is the limiting reagent by using, first of all, what you will write, H2 plus Cl2 gives HCl. Then you will have to balance this also. Okay, so do this. ये हो जाएगा आपको वो से. Calculate the MCR of hydrogen, calculate the MCR of chlorine, then determine the limiting reagent. Then you have to determine the amount of Cl formed. First of all, balance this reaction. H2 plus Cl2 gives HCl. Guys, 2 more minutes. Got one answer. Mm, can you show me the calculation again? Time is almost over. See, once you balance this, you will get 2 moles of HCl like this. So if you calculate the limiting reagent, you have to calculate the MCR. So 22.4 liters of H2, that will give you 1 mole of H2. 11.2 liters of Cl2, that will give you 0.5 moles of H2. Okay. The stoichiometric coefficient for both of them is 1. So MCR भी अगर हम calculate करें for H2, MCR of H2 will be equal to 1. MCR of Cl2 will be equal to also 0.5, the same thing. So you can see that Cl2 is what? It is the limiting reagent. So you can do MCR of Cl2, that is 0.5. It is equal to the MCR of moles to coefficient ratio. So moles of HCl divided by 2. So this will be number of moles of HCl will be equal to 2 into 0.5. That will be equal to 1. That's it. So option A, 1 mole of HCl. Alia and Hiran, does this make sense? Yes or no, please tell me.
Yes.
Yes, sir.
Please focus down. So you have copied this down. The same question, no? That will try this. 10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. That means they were heated up. So when you have H2 and O2, obviously water is going to be formed, hydrogen and oxygen. You will form water. What is the amount of water formed? Write the chemical reaction, balance it, determine the limiting reagent by calculating MCR for hydrogen and MCR for oxygen. Once you're done with that, you will do MCR of limiting reagent is equal to MCR of the product, and you will get the moles of water. Okay, this should be done. Please take 2 minutes for this. Okay, I've got the answer. I'm gonna have 30 more seconds. See here is H2 plus O2 will give you H2O. In order to balance this, we will have to write 2 moles of O2. Okay. Now we'll calculate the MCR of H2. MCR of H2 will be equal to, the number of moles will be equal to 10 upon 2, and this will be divided by 1. So this will give you only what? 5. Okay. 5 mole. Rather, 5 is just a number you have to remember as a number, nothing else. Then we have the MCR of O2. The number of moles of oxygen will be 64. That will be divided by the molar mass of oxygen is equal to how much? It is equal to 32. 32. So whole thing will be divided by 2. So you see that this is 2 and 2 2s are 1. So MCR of O2 is lower. That is why we will say that we would require what? We will require MCR, I mean, oxygen is a limiting reagent. Now, according to the reaction, you can do it because they are just asking for a number of moles. So if you have 1 mole of H2, 2 moles of O2, it gives you 1 mole of H2O. That means whatever be the mole of O2, whatever is the number of moles of O2, you are getting half of that. Okay. So how many moles of O2 we are having? So 64 upon 32, that is equal to 2 moles of O2 we are having. So we'll get 1 mole of H2. If you're not comfortable with this, then you can do it in this or in this way also. MCR of O2 is equal to MCR of H2O. MCR of O2 we have got it as 1. MCR of H2O will be equal to what? Number of moles of H2O divided by the stoichiometric coefficient, that is equal to 1. The number of moles of H2O कितना आ गया आपका? 1 आ गया. That's it. So 1 mole will be the correct option. कहीं से भी कीजिए आपको 1 mole ही आंसर आएगा. 4 नहीं होगा ना. 1 mole होगा. देखिए कहाँ पे गलती की थी आपने. Does this make sense, Iram, now? जी, Iram, tell me. Moving on, try this. What volume of oxygen gas measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas measured under the same conditions? Okay. So this is nothing. You have only dealing with the reactants. So you will do MCR of one reactant is equal to MCR of the other reactant. So MCR of O2 should be equal to MCR of C3H8. Okay. MCR of, so by the way, what will be the reaction? The reaction will be C3H8 plus O2 gives CO2 plus water. This is the combustion reaction for any organic molecule, that is any hydrocarbon. How many moles of carbon atom? There will be 3 moles of carbon atom. How many moles of water? Because there are 3 carbons, 3 moles of CO2. Because there are 8 hydrogens, I will write 4 H2O. So how many oxygen atoms do we have? We have 3 to the 6, and here we have 4. So we have a total of 10 oxygen atoms. That is like 5 O2. Okay. So this is the complete balanced chemical reaction. Now we'll calculate the MCR. MCR of O2 will be equal to the number of moles of O2 divided by what? Divided by the stoichiometric coefficient, that is equal to 5. This will be equal to the number of moles of, we have 1 liter. So 1 liter will be equal to what? 1 upon 22.4 divided by what is the number of moles of C3H8? It is, sorry, what is the coefficient of C3H8? It is equal to 1. The number of moles of O2 that will be required will be equal to 5 upon 22.4. Now we have to calculate the volume. So what is the relationship between volume and number of moles? So volume of O2 divided by 22.4 will be equal to 5 upon 22.4. Because number of moles, the number of moles we can write V upon O2 and 5 upon 22.4 is as it is. So volume of O2 will be equal to 22.4, 22.4 can cancel each other, and you will get volume of O2 is equal to 5. By the way, the number of moles thing is also valid for volume. जैसे कि मान लीजिए आपके पास, if you see here, 1 liter of, as we said, 1 mole of propane requires 5 moles of O2 to give 3 moles of CO2 and 4 moles of H2O. The same thing can be said for the case of volume also. So 1 unit volume of C3H8 requires 5 unit volume of O2, requires 3 unit volume of CO2, and 4 unit volume of H2 if everything is in gaseous state, that is at STP. Okay. And if I have, for example, if I have 2 liters of C3H8, then I will require 10 liters of O2, and it is going to give me 15 liters of CO2. The mole case is also valid for the volume case also. Okay. Moles और volume आप रख सकते हैं साथ में only and only if it is at STP, that is 0 degree Celsius and 180 pressure. Does this make sense? Yes, somebody tell me, Aram, Alia, and Nabil.
Yes, sir.
Yes, sir.
Okay. So आज के लिए ना इतने रखते हैं because I don't think that I should start solutions right now. We have only 6
Sure.
minutes remaining. Yeah.
Sir, show me the previous one. Sir, ये आप explain करेंगे?
Sorry.
Sir, ये आप explain करेंगे फिर से?
Just give me a second. Starting से.
जी.
First of all, we'll calculate the MCR. है ना? So MCR we got. What did we get as MCR? Wait a second.
Sir, O2 2 मोल हुआ ना?
O2 2 नहीं होगा, 1 होगा. H2O 2 होगा ना?
नहीं, H2O.
Sorry, balancing दिक्कत है. Sorry. Thank you. Balancing was not right. H2 would be 2. H2 would be 2. Second, H2 plus O2 gives H2. So this will be 2 and this will be 2. So I have to calculate once again everything. MCR of H2 will be equal to 5. This will be 10 divided by 5 into 2. This will be equal to 1. Correct, huh? 1 होगा ना? अच्छा, यहाँ पे number of moles ही अलग हो जाएगा. MCR of O2 is equal to 64 divided by 32, that is equal to 2. Okay, MCR is itself different. So MCR of H2 will be equal to 1. Okay, so the number of moles of hydrogen that we are having. फिर भी तो 4 नहीं आएगा. MCR weight is divide that's all. Divided by 5 तो क्या हमने यहाँ पे divide by 2 होगा. ठीक है.
So यहाँ पर 2 moles of oxygen. 1 mole of oxygen, 2 moles of water.
एक सेकंड, मैडम आपकी आवाज नहीं आ रही थी. से 1 mole of oxygen and
Sir, 1 mole of oxygen 2 moles of water बना रहा है, right? पर यहाँ पे MCR में हमारे पास O2 2 moles है, तो 2
नहीं
moles
सही है.
of oxygen
ठीक है,
4
सही.
moles of water बनाएंगे.
नहीं सही है, आपका सही है. नहीं, my calculation was wrong. Like my equation ही हमने यहाँ पे गलत लिखा. That's correct. ठीक है. So here they are saying the MCR of O2 is equal to 2. So 1 mole of O2 it gives 2H2. So 2 moles will give 4. You can use this also. MCR of O2 is equal to MCR of H2O. MCR of O2 is equal to 2. MCR of H2O will be equal to number of moles of H2O divided by 2. Number of moles of H2, moles upon coefficient. So number of moles of H2O will be equal to 4 moles. So मेरा वो पहले ना इक्वेशन ही गलत था. I did not balance it correctly. Instead of writing 2 for the H2O, I wrote 2 in the place of O2. ठीक है, that is why the complete mistake was there. इसको प्लीज कॉपी कर लीजिए बाकी लोग. तो वाला काट